skal jeg gerne snakke højere.
Okay, we're ready for our next talk. It's Loke Dupont who's going to talk about serverless applications with Amazon's Lambda system. Let's give a hand to Loke.
Thanks. So yeah, I'm gonna just quick intro to who I am. Work mainly with video streaming for a company called Extreme. We decided to move pretty much all of our services into the Amazon cloud about a year ago. And so I've been trying to preach to the rest of the organization why we should use all the AWS technology we can. So a quick introduction to the AWS stack. Most people are familiar with the three classic services of AWS, meaning EC2, RDS, and S3, which is respectively, EC2 is sort of a standard virtual machine. You boot it up, run the software on it, you can install whatever OS you want on it, and it runs just like if you had another VPS at a random host somewhere. RDS is basically Amazon's way of running database servers. It allows you to run database servers in a managed way. So you can of course run them on EC2 yourself, but using RDS, it has a bunch of stuff on top of it that handles failover capability, handles having replicas in another region, and it supports a number of different database engines such as Oracle, Microsoft SQL, MySQL, MariaDB, and their own sort of modified version of MySQL called Aurora. The third component of the classic AWS services is S3, a very nice storage system for storing large amounts of data. In fact, Dropbox used this initially, I think up until about a year ago. They were using S3 as the backend for all the Dropbox storage because it was just easier and cheaper than trying to build it from the ground up, basically. AWS Lambda is a relatively new service. It was introduced, I think, approximately a year ago, and it's designed to sort of be the glue between a lot of other services. So it has a number of integrations towards S3, something called Kinesis, which processes stream data. So if you have a lot of events coming through, you want to process them in an efficient way, Kinesis has a lot of functionality for that. It also has integrations to another new service called API Gateway, as well as their notification system. So pretty much everything in the AWS system can send out notifications when an action happens. So for instance, you can listen for notifications on when a new machine starts, if a machine gets terminated, if a database has an error of some kind, and they'll all pipe it into SNS, and Lambda can actually listen to SNS topics. What could you use it for? We could have a Lambda function that basically reads Kinesis data. So if you have a log events, for instance, you're streaming into Kinesis, that like millions of log events per minute, you can actually have a Lambda function getting all that data fed in, and Amazon will run that as much as it needs to, and run every time you receive new events. We can also use it for, if for instance, we can listen to when a file gets created in S3. So imagining you have a number of users uploading images to an S3 bucket, you can listen for the object created event, and you can then have AWS run Lambda every time that happens. I actually have a demo that demonstrates that particular thing. Or it can just be that you're monitoring jobs for one of the long-running jobs you have encoding video, for instance, and you can want to check when it gets terminated or when it's done. And then one of the very nice features as well is you can run classic web services using Lambda by having API Gateway in front of it. So the first demo I have is an automated encoding solution. Basically, the flow of this is that we have a video that goes into S3. That triggers Lambda. Lambda sets up a new transcoding job and sends it, of course, to Elastic Transcoder. Why not use the AWS stack the whole way through? Elastic Transcoder then sends notifications when it's done encoding, if it's successful, if it failed. It'll also send progress updates. And each time Lambda gets called again to update a database of what the status is of the encoded files, and also to send a notification if encoding fails, for instance. In this sample, it sends an email to a designated address saying that the encoding failed. And if we just tap out here, I can see there. What? Yeah, it's probably just zoom in a bit. Oh, it's going to be tough to read. So I have 3 Python files. This one is the one that actually creates the encode. I'll show you how that looks in the Amazon console afterwards, but basically it just listens for the handler function is called every time Lambda calls the function. Yeah, I can zoom in further, sure. Perfect. The Lambda calls the handler function each time a new event is triggered, and in the event, it basically sends us the name of the new S3 file. So what we do is we create a transcoder job, and we give it the key, input key, which is basically the file name, and we also choose an output name. Says what profile we want to transcode it with using the preset ID. And then we add some metadata that says initiated by Lambda, just so we can identify it if we're looking in the Amazon console. It also prints the transcode ID, which means it gets put into the log file, and then it puts an entry into the DynamoDB table saying this file is encoding. So, if we switch to upload a file, let's grab a video file here. You probably can't see the file names, but this is basically me dragging and dropping a file over to the S3 bucket. And luckily we are on a fairly fast connection, so this should be about a minute. In the meantime, I can take you into the Lambda console. And I should probably zoom that as well. So we have our three functions here. This is the case we have the autoencoder. If we look at this function, we can see, we'll just go into it here. We can see the triggers for it, and there's an S3 trigger. So each time this particular bucket has an object created, this will trigger the Lambda function. And this should mean that when the file is finished uploading to the S3, we should get a trigger of this function, and the code you just saw will then create a transcode job. So let's just keep an eye on when we have that uploaded. Still half a minute yet. We can also monitor the jobs, so we can see how many invocations Lambda sent for this job, if there's any errors, if there's a number of issues with throttling, and how long they were running for. One of the caveats of using Lambda is it can only run jobs that finish in less than 5 minutes, which is plenty for almost all functions, but it means you can have long-running background processes. See, our file is now uploaded, and what we can then do if we take the let's take the Elastic transcoder. We should then show that we have a job running in the pipeline. Let's grab the Lambda pipeline. And we can then search for the jobs. Lambda pipeline, jobs. And we have indeed a new job encoding, marked progressing. And we also should be able to see in our DynamoDB that if we go to the correct table, that we have an entry there that basically says the same thing. There it goes, input key, output key, status encoding. And so when that completes, the Elastic transcoder will fire off a new event saying this job is now complete. We can look in our database saying, okay, this is 1 hours, and then we can trigger a function to remove the original file, because of course we don't need that anymore. If it fails, we don't trigger that function. Instead, we trigger the function that sends an email. And this will take a little while. In the meantime, I'll just drag over a file I know it can't transcode. So we'll just move that over there. And this will trigger an email to me as soon as the Elastic transcoder figure out that this is not something we can transcode. So let's see if we have any luck with that. Yep, there it goes. Triggered the email saying transcode failed. Error code 4000, this was the ID, and it couldn't interpret the media file. So basically, all of these actions are triggered automatically. There's no server running monitoring all of this. It's only triggered when the notifications run. If we jump back to, I'll actually just refresh this. We can see it marked as failed, the other job that failed, and we can see that Elysium trailer is now marked as completed. If I go back here and refresh, we can see one of the files disappeared. That's the one that's successfully encoded because we cleaned up the job. And we can see in the different bucket that we now have a new file. That is a transcoded file. All of this triggered by Lambda in an automated fashion. So, what if we don't use AWS? All of these events are pretty useless if we have our own infrastructure. Well, not really, because we can still have the API gateway. There are two major frameworks that allows us to use the API gateway in a much less painful fashion. Using it raw can be a little bit of a tedious process. There's one called serverless, which is based around Node, and then there's a relatively new one called Chalice, which is based on Python, which I highly prefer. So of course I went with Chalice. It's basically, it looks like Flask, if you're familiar with Flask for Python. It has pretty much the same API. It will create all the API gateway mapping functions for you. And it also generates what Amazon calls an IAM policy. So the way things work is if you're executing them in AWS, you have to give them permissions to use other AWS resources. You can't just have Lambda get permission to use everything in your AWS account. So what you do is you generate an IAM policy that says this function, when it runs, can access these resources. And Chalice will do that for you in most cases. There's also cases where it doesn't apply, unfortunately. And get you started with as simple as saying pip install Chalice, new project, and then deploy the project. So I'll try and show you how that works. We'll just, this zoom is probably going to be an issue here. We'll just try and do this as well. So we have a new, we have Chalice installed. So we say Chalice, new project. Let's say Bornhack demo. Is it? Oh, I'm not in the right one. This one. Of course, needs to be in the right Python environment, otherwise it doesn't work. Chalice. New project. Bornhack demo. And it generates a new folder. We can cd into that, Bornhack demo. And then we can do Chalice deploy. And it'll deploy a simple hello world function for us to start with. As you can see, it runs through all the different actions that we would have to do manually, but this automates it a little bit. And of course, it's also slow now that I'm demoing it, because that would be too easy otherwise. In the meantime, I can actually, there we go. First time deployment, deploying to dev, and then it gives us a nice URL, which we can then, of course, call with curl to see that it actually is working. Notice also it sets up HTTPS by default, which is very nice. You don't have to handle any of the let's encrypt stuff yourself. Call the API, and it should give us a hello world JSON reply. There it is. Now, if you want to look at how the code actually looks, let's open an editor with this. And you can see we have a simple Flask-like app root, and it just returns hello world. Now, that is much fun. So I have a pre-prepared changed version. I'll just grab that. We'll just copy. And that should give us a modified version. Yeah. This now has two new functions. It has a notify that sends a text message. And because I don't want everybody just calling that, I marked it as AP key required. That's a API gateway function. That basically means it'll enforce authentication on this function. So we don't have people sending me texts using this API just randomly. And then I also created a function that looks at the encoding status of the files that the table we just saw in the previous demo. So if we now go back to Chalice, we just need to do one more thing, because as I mentioned, Chalice also does the IAM policies. In this case, with this project, unfortunately it fails. So luckily I also have a prepared version of that. It's called policy.json. I copy to here. And then I'll say Chalice deploy, no, also gen policy. This should update the function in the development environment of our API gateway. And this means that if we now call encoding status on this API, we should be able to see the status of the failed encode that we had just before. So let's do curl. Copy paste this. And then we have encoding status was the new function, stream npd. And it should list the encoding status from the DynamoDB table. And it does. So everything is working. It's now actually talking to a database on the back end. And it didn't take more than just a few lines of code to check the database. Also note that because I'm running all of this in AWS, I don't have to have any passwords for the database in here. I'm basically just asking for a DynamoDB resource, and it just gives it to me because I have a IAM policy that says this Lambda can ask this table at any time. So I don't have to have passwords in the code or in a config file somewhere I have to maintain, which is a nice benefit. But that's all very nice. But what if I have an existing non-AWS implementation and I don't want to start building everything from scratch with Chalice? Well, actually, there's a way for that as well. There's a project called Zappa, and of course, this is again, I like Python. It can actually take pretty much any Python application that has a WSGI interface and run it on AWS Lambda. So that means you can take something like written in like a Django framework, Flask, pretty much any other framework, and you can have Zappa deployed for you in AWS Lambda, so you can have a Django application running completely without servers anywhere. And just like Chalice, it's very simple. You install Zappa, you say Zappa init, and then you basically deploy it, and it'll run the application in AWS. And I have a demo of that actually as well. So let's grab the Zappa version. We have here a pre-prepared Flask application. If I cat the app, you can see that there's completely standard Flask application. Nothing has really been changed. We're just going to run Zappa init. And it asks us a bunch of questions like which environment will you want to deploy it in. Let's say we want it in development. It also creates an S3 bucket to handle some of the data storage. We'll ask the default name. Oh, and then it discovered that there's a Flask application here. And do you just want to run the default application? Yes, we do. Good. There's a settings file. Perfect. That looks okay to me. One thing in this case is I want to change the Amazon region because by default it'll try to run it in the US, and that sucks. So I'll just modify this and say, okay, we actually want the region EU Central 1. And then we ask Zappa to deploy it. Zappa unfortunately has the slight drawback that it will take a long time to create API gateway routes because it has a sort of, it doesn't yet understand the mapping of your URL, so it creates just routes for everything. As you can see here, it creates 1,007 routes. Other than that, it works, but it is a little bit tedious to deploy it first time. Second time, it happens automatically. But once it's deployed in API gateway, we can call it the same way as we call the Chalice application. It just works out of the box. So Lambda gives us the ability to do completely automated scaling. We don't have to set up how many Lambda instances we want to run on. We don't have to prepare or preheat servers. We don't even have to care about installing the operating system. All of that is done automatically. We don't have to update the operating system. We have to only update the code that we put into it. We pay only for the requests, which means that we can pretty much predict what our cost is based on how many times our API is called. And 20 cents per 1 million requests doesn't seem like a lot of money, considering. And also, that's, by the way, the first million is free for you to experiment with if you want to try it out. There is some issues with it. You can only have code that's about 50 megabytes zipped, because what happens is when you run the Lambda function, Amazon will take pretty much an empty virtual machine with just Amazon Linux on it. It'll take down the package on the machine, unzip it, and run it. And for that process to be fast enough for the first start-off of a new virtual instance, they have to keep it somewhat contained. It also has that's actually a typo, that's 1,000 concurrent requests. That's the default limit, although that can be raised if you ask Amazon for it. But it means that you can scale and pretty much not worry about having virtual images. You don't have to worry about creating Docker images or anything. Just upload the code, and it runs with Python, Java, Node. And since it runs on a standard Amazon Linux box and there's no sandboxing, you can actually also upload custom binaries that are compiled for Amazon Linux. And you can just run them from JavaScript or run them from Python, and it'll work as well. You get access to the whole box, no weird sandboxing anywhere. Another nice feature is we have the API gateway that's in front of it if we're calling the API. It has built-in authentication, and it actually has a concept called usage plans. So if you have third parties using your API, you don't want one third party basically completely hammering it for no apparent reason. So you can set up and say, okay, these users fall into this category. They'll be throttled to 100 requests per minute by default, and they only get 100,000 requests per month. And then you can actually have different usage plans, so you can put them into buckets and say, okay, this is a like small users, medium, large, and so on. And also has dev, staging, production, so you can maintain different versions of your API. Questions? Apparently not.
Anyone? Doesn't seem like it.
Cool.
Let's give Loke a hand.